Our lovely ZFS panel today. They will be modeling in their bathing suits later, or possibly sooner as it gets warmer in here. So we wanted to put together a panel and talk about the state of ZFS on various platforms, get a kind of an overall state of the union for everybody. Did you want to make any other introduction remarks?
I guess most of us have spoken today already, but Don, would you kind of introduce yourself and so people know who you are and what you're doing?
Hi, my name's Don. I worked it out for a couple decades. I worked on the ZFS port there, and then recently did a report from ZFS to macOS.
Cool. Get started.
All right, so the questions we have that we'd like each of you to answer in turn is to give a little history of ZFS on your particular platform, when the project started, who started it and why, in other words, what motivated the work, and when was your first production quality release. So we could just start, we'll go down the road.
So, yeah, I kind of gave that history of ZFS at the beginning. That's what's now in illumos. So I guess what motivated it was, a lot of it was to end the suffering of system administrators that we had seen and experienced at Sun, and to create, the next generation storage system. And the first production quality release is an interesting question. I'm going to say
2012.
So Slur Send Update 2 was the first supported release from Sun. Was that in 2006? 2006. And I think, by 2008, it had really, matured and become part of the storage appliance. And so I'd say somewhere between 2006 and 2008.
So I think I covered a lot of this actually in my talk, why we did it. But we started back in 2007, I would say, looking at it and saying, we need ZFS. And then it was more of an effort to see if this was even feasible on Linux. Linux is just different than all the other platforms, so we weren't sure how easy it would be able to map ZFS onto Linux. But we did it, and it was good. As for when it went to production, we're in production today with our big system. So, well, I haven't tagged a stable release. I would say it is probably pretty close to that now. So 2012, hopefully by the end of the year, we'll have a real production release.
Stereo.
Redundant.
Why I did ZFS? Well, actually, I was a tech lead for HFS, and if you've seen the Sausage Factory, you just I knew there was a better solution. So that's what I was personally motivated to do it, and I've had it on my systems for the last 6 years on my laptop, and all my data in my house is on ZFS, and I actually sleep at night. So. Production, I'm at Green Bytes now, and we did a community edition, a free community edition about 2 weeks ago. And I'm like Brian, I'm more conservative. I use it with all my personal data. I implicitly trust it, but it's a hard call to say like when it's stable, because there's always issues. But I think it's good. It's solid.
So I think that the timeline on the FreeBSD port was kind of covered in the early presentation. PJD started probably in 2006-ish, something like that, playing around with ZFS. Only he can speak to his motivations. But I think the rest of the FreeBSD community is pretty excited about it because UFS is in a lot of areas is very capable, but when you're talking about larger systems and certainly if you need more flexibility in how your data is managed, there's just no comparison with ZFS. And so it basically brought a forward-looking file system to FreeBSD. I believe that the first release that most people trusted their data to ZFS on FreeBSD was in 2008 with FreeBSD 7 something. And it's just gone from there.
I personally run FreeBSD with ZFS on my machine at home, but that's all I did so I can do production. There are a couple of features that haven't been completely ported from the original version. And then talking about the new changes that we've done we've been very conservative about pushing those back, about using them in production, precisely because they are used for everything in ZFS. So I can definitely relate to how you guys feel about it.
So for each of you, for your specific platform, what platform-specific integrations have you done? Presumably because you had to.
So when we were originally doing ZFS, I think we thought that it was going to be really easy because all that we had to do is interface with the VFS layer at the top, implement the vnode ops, and then talk to the devices down at the bottom. Done. But we found that there's a lot of other pieces of the system that want to touch ZFS, touch the file system. So like booting, ZFS boot didn't exist for a long time, and it was kind of long lamented by our customers, and was pretty challenging to do, both from the so in Solaris we used Grub as the bootloader, and so we had to implement ZFS for Grub to be able so that Grub would be able to read from the ZFS file system, but then also like the rest of the parts of the kernel, so just getting the root file system mounted was special, so we had to do that specially. And then I think like integrating with the fault manager, the Solaris fault manager was another big challenge. So.
I think there's actually a lot of facets to this question. So when I came upon ZFS, it was actually largely done in a lot of respects, right? The whole core of ZFS was there. The problem I had was on the periphery of ZFS, right? I was integrating it with how exactly you talk to the Linux disk subsystem, right? And do block I/O. The interfaces there are completely different on Linux than on Solaris. And once again, like at the VFS layer, where it touches the normal POSIX file system, those interfaces are completely different on Linux. So while the core of it was sound and solid, where it touched Linux really needed to change a lot. We tried to minimize that as much as possible, but you can only do so much. So we spent a lot of time getting that integrated right. Things like fault management also aren't there yet on Linux, so we need to do that. It's kind of pending work, but that's once again periphery stuff that needs to be done to make it work in a real production sense, right? And actually, the community has been real helpful on these kind of integration details. So like I mentioned before, with Linux, all the distributions have a different way of doing things, right? And there's no way one upstream can support them all. But once the system was basically functional, so that modules in a file system you could mount, lots of people came up with had their favorite distribution, how it should work, and they just jumped on it, right? They took the modules, they got it to work with Grub, right? We had people pursuing patches to get Grub to read the latest on-disk ZFS formats to be more reliable about it. So independent of any work at Livermore, just because it was out there for Linux, we got better Grub support, right? And that was all community driven. There's been a lot of integration efforts like that, I would say, on Linux that weren't guided anyway, but just happened. So it's been interesting.
I actually have another question. Like in Solaris, it was also a big pain to do swap and dump support. Do you have anybody's working on that for Linux?
So swap support was actually finished, I would say, a month or so ago. At least the initial implementation of it. It no longer deadlocks. You can use a ZFall as a swap device now, and it's at least safe in the sense that it doesn't deadlock. There's some more work to be done on that to make it a little more performant, but that works fine. As for dump support on ZFS, I haven't tried it yet, but I think it's probably fine because Linux doesn't do anything too special for that. And having made it be safe for swap, we've run down a lot of the deadlocks in the memory management, which is actually another big issue with ZFS on Linux, is the memory subsystem is completely different in Linux than Solaris, and there's been a lot of work there to improve things. It needs a lot more work probably to be faster and more performant, but at least it's stable and correct now.
There's quite a few things. I'll just talk about some of the user level, like interesting scenarios that we ran into. The first one is dynamic devices. On the Mac, it's plug and play. You take your FireWire disk, you plug it in. When you're done, you eject it in the Finder, and you're on your way. So this notion of an implicit import is sort of a foreign concept. So we decided there's already a mechanism in IOKit for probing devices, and it'll contact you dynamically. So instead of a zpool cache, which is like a static declaration of your storage. We dynamically build it up on the fly when you plug it in, and as soon as we get critical mass, we go ahead and import, and if a straggler comes along, we online it. It works nice. It meets that expectation. And likewise in the Finder, if you do an eject, the expectation is you're going to export that thing and they can just unplug it. It's not the same as in the terminal doing like a ZFS unknown, which is just taking the file system offline. So there was those type of dynamic mappings that we had to consider. And there was quite a bit of subtle bugs that I feel like no one else would appreciate my pain. It's like in the Unicode space, there's actually two different ways to store several characters, like an accented E on the Mac traditionally is stored as an E and an accent character. When it's rendered, they composite them. And on any other platform, they just store a composite character that's already one glyph, one character. So on the Mac, without intervention, you can get into some nasty problems because the Finder stores it one way, the terminal shows a different way. So you can actually go into the Finder and create a directory, cafe, and then go into the terminal and touch cafe. Then you have two objects. You have a directory and a file with exactly the same name, which is, it leads to all kinds of interesting problems.
Well, the name looks the same.
It looks the same. Unlike case sensitivity, where you have a differentiator, there's nothing. It's like, and in the Finder, depending on the Finder view, you get different experiences. Sometimes you see two folders, sometimes you see a folder and a file, and sometimes you see one folder. It's like, it's just bizarre. So, unfortunately, I'm not sure we did the sys works, but there's a Form D explicit setting. So on the Mac, we highly recommend, and that, in fact, that's the default. You should use Form D. So then that problem, you can't do that. When you do the touch, it'll actually map it back to the correct one. You pay a little bit of an overhead, but you can keep your sanity, because it's crazy to have different stacks using different variants of the encoding. And then, of course, file systems. I think Bill had alluded to sort of resource constraints. On the Mac, they're, unlike on illumos, they're not lightweight. File systems implicitly have to have a device backing them. That's just assumed in a local file system. So we have to make virtual devices for each one. That alone is a pretty hefty cost. But there's the spotlight indexing, FS events, all these system tasks that are assuming that they're the only one. There's only one device, and so if you have multiple file systems, you get this multiplier of taxation that can really impede your performance. Yeah, and then of course there's the resource issue, memory, things like that are completely different on the Mac. So kernel memory on the Mac is like a very precious resource. It's wired. You're not expected to use much of it. It's unlike a server. Applications get it all. So it's a challenge to sort of manage that in a way that's responsible for the platform, and yet meets expectations of like the ARC being able to cache something. So.
I think that the thing we're just talking about with dynamic devices is actually really interesting for us, in that FreeBSD also has an underlying device layer called geom, which has this concept of being able to taste devices as they arrive. And I don't know why the port was done the way it is right now, but that tasting mechanism in geom is completely bypassed. And in FreeBSD, we follow kind of the Solaris model of having a cache file and explicit import and export events and things like that. And that actually, at SpectraLogic, became kind of an issue in dealing with fault management, because we encountered race conditions between events getting delivered to user land, and then we'd go to revalidate the configuration and find the configuration had changed because the kernel could see that a device had arrived or departed or whatever. So this schism between the state as seen by the kernel and what's in user land created several issues for us that we had to reconcile. And so it'd be really nice to go back to a model where the kernel understands, because that mechanism already exists, what devices are there, aggregates the pools, and then basically user land just gets to query the kernel and say, what do you have? Which pools do you have? Oh, there's a foreign pool that I could potentially import or whatever. So it'd be nice to come up with a scheme that works for all the platforms where even if you don't have this concept of dynamically tasting a device when it arrives, you could simulate that by having user land present the device to the kernel and say, please taste this for me. And that would also allow you to do things like ZFS on top of files, right? That's the one case where, at least in the FreeBSD world, we're not tasting files to find out if they have a ZFS label on them. But you definitely need that capability to be able to do things like the Slayer's test suite and things like that. Other things in FreeBSD that, just off the top of my head, are different a little bit. In our ZFS boot implementation, there's a new thing coming around, next boot. So we've had this feature for some time on UFS, where you can basically say, the next time you boot, try this thing. And if it doesn't work, well then we'll fall back to where it was before. So that same concept is being applied with ZFS, and so you have the opportunity to be able to specify a different boot pool for the next boot, try it out, and then fall back. So that's coming. One other thing that we've been talking about at Spectral Logic, a lot of these motherboards come with fake RAID built in, and a lot of appliance vendors end up using fake RAID maybe for their boot system or whatever, or I guess it sounds like in the case of joint, use a USB key. In our environment, we would like to be able to just use ZFS for all data protection, including the boot devices. And so we've been talking about extending the FreeBSD EFI loader so that we can make that into an application and just embed it in our BIOS. And that way we completely replace the fake RAID that comes from Intel or Supermicro, or whoever it is that provides the service. And it's basically the same data layout, the same code, the same testing, all goes into the same data protection throughout the system. You probably have other ones that you'll remember.
Okay. So one of the platforms typically with that certain ZFS tunable and thus it coded for 52L, which is a standard interface for accessing, read-only, read-write information FreeBSD. And I think in the large it's MDB.
Or KStat.
Yeah. And on Linux it's /proc. There's things like that that are very platform specific. And I think it would be helpful if we had a more standardized way to deal with that.
So you're talking about like the things that we tune in Etsy system, where like in Slayer, we just have like a global variable that you can change by changing this file Etsy system. But it sounds like there's a different mechanism in FreeBSD.
Yeah. So, for example, you can tune the rubbing behavior of ZFS by changing the tunable using MDB and illumos or 50T on FreeBSD and get the file and that. So, just things like that I think would be really helpful to, pulling our efforts together.
Like we could consolidate all of those different tunables into like one data structure, like one array of things that you can tune, and then each platform has a different way of actually accessing it.
Yeah, different way of rendering it, I would say.
Yeah.
Cool. So the next question is about interoperability. Is that correct?
Yeah.
What Z-Pool versions and features are supported on your platform, and did you have to make any platform-specific on-disk changes?
So the most recent version that illumos supports is this version 28, which was the last version that was developed at Sun and Oracle, and then the feature flags that we've implemented on top of that, what's it called, background asynchronous destroy, and then the empty BP objects, which is a little performance improvement. I'm curious of you guys, like if you support all that stuff, if you needed to do other specific like on-disk changes to support, like I know Don, you've done some stuff in the ZPL space to support special files, special file types that are applicable to Mac.
All right. For Linux, actually, we started at the same spot. We've got the latest version, ZPool 28, that came out of Oracle. We fully intend to implement the feature flags. It's work that's pending. It's not in our tree yet. We're pulling in some of the requirements from illumos still, but we will have feature flag support. Other than that, we're pretty much features complete with 2 exceptions compared to the ZPool 28 version. We don't yet implement ACLs properly because Linux supports POSIX ACLs, and there's issues there, right, with compatibility with an NFS ACL. So we don't have ACL support yet. We also don't yet support ZFS delegations. Other than that, everything's there that you expect. As for features,
so you're talking about like the ZFS allow
yes,
stuff, right?
Yeah, ZFS allow. I think, yeah. that kind of feature. So right now, all the commands have to run as root at the moment on the Linux port. You can work around that any number of ways by setting up groups or permissions or whatever, but we don't have ZFS delegations right now. As for on-disk format changes, the only significant one we've made, and it's off by default, you can enable it if you want to, but we've improved extended attribute performance. This was work that was needed for Lustre. So we actually allow you to store small extended attributes now if you turn the feature on in the system attribute space for ZFS, which makes EAs much faster. We needed that case to be fast, so we added that. But if you do turn that on, I don't think the EAs will just be visible on other platforms. So it's not harmful in any way, but it's there.
And how was that done? Did you add a new attribute, first-class attribute?
No, actually, we just modified the xadder property. So you now, instead of, it used to be on-off, now you can set it to SA as another option. So
that was actually kind of a bad way to do that, actually.
Oh, why?
The way you should have done that was to add a new first-class system attribute to, for a new attribute type field. It was just a get set model.
Maybe. I have to give us more thought. But what we did at the moment is that. As soon as we get the feature flags in now, we'll probably end up retrofitting that with the feature flag anyway, so we'll have a chance to revisit that.
Yes, it would be file system independent as long as you're at version 5.
Okay.
That's interesting because it would be like a ZPL layer change. So we actually haven't implemented feature flags at the ZPL yet. So it only covers the zpool version stuff.
Okay.
So that'd be an interesting thing to chat about. I think Don probably has similar issues with.
Yeah, in that same sort of EA space. The thing about EAs is on Solaris and on Windows, they're really streams, and it's a different model. On Linux and the Mac, they're lightweight name value pairs. And so the usage model is different. So mapping those to a directory, to a file system layout is not performant for our cases. So on the Mac, there's this one in particular called the Finder Info, and that everybody wants that. So we actually map that into the SA space. It's a first class SA. And we added this notion of a alternate parent, because on the Mac it's highly dependent on, you'll get blind inode lookups, and you really need to be able to traverse your parent chain. But in the current Solaris implementation, or the illumos, whenever you do a link, that's your parent, basically, every time you do a link. And so if you do a link, a temporary link, and an unlink, then now you're an orphan, you don't have a parent. And so the idea with the alternate parent is that's the first guy. So you cover sort of the 80% case where someone, if you do a temporary link, you at least have an alternate parent that we can rely on, because we're highly dependent on that. So we added a couple essays. And then I think it was macOS 10 Lion had this concept of added date. So like if you're viewing your Dropbox, you can see things when they were added, not necessarily when they were created or modified. And so we added that special date field. So extended attributes is one area. And then another, I don't know if it's a bug in the illumos stack, but if you try to set extended attributes on a symlink, I'm getting corrupt SAs. And so I don't, because there's no API to do that. illumos has never been tested.
That's a bug.
Yeah. Okay.
I put that was actually, I fixed that in illumos like 2 weeks ago.
Ah, cool. Yeah, because Linux and Mac have an API to do that, and actually people, reasons I don't understand, actually do put extended attributes on.
There's a problem with the SA code when you have variable length entries. Like if you have multiple variable length entries, it's like we just didn't happen to do that in illumos, or at least not very commonly. But I think somebody reported this bug from Linux?
I think it's FreeBSD.
Somebody from FreeBSD was doing this.
It wasn't around the verifying.
Yeah.
The layout, yeah. It was fixed about a year or so ago.
Oh.
Solaris.
Cool. So that should be in the illumos.
Yeah, that's in illumos trunk.
Do you know who put that back?
I did.
I'll look for you. Because I had to turn that off, and people were complaining that I can't set an EA on my symlinks.
Don't do that.
Don't do that. There's some other, back to the subtleties, it's like some marketing guy in the hard disk space decided that if you divide by 1,000, you get a bigger disk instead of 1024. And so on the Mac, that's the convention. I think it's on consumer platforms. So that's a big sort of sword point between the Mac, when you're in the Mac interfaces. So as a sort of workaround, we use the GI to sort of reinforce that this is a Power 2 base, and that's why it's it's like your 2 terabyte disk is only 1.8 or something. So there's things like that where standardization might be helpful. We had mentioned disk on disk, and what I'd like to push for is to have a standard GPT layout with a specific ZFS GUID, because that's helpful for like probing mechanisms so you can register, I want GPT with some special ZFS one. I know that FreeBSD has a different one, the Mac has a different one, and I don't know. So it'd be nice to maybe standardize that. But
so on FreeBSD, if you're on the bleeding edge in current, we're pretty closely tracking what's in illumos. So we have v28 plus feature flags. I know that we have, I think the asynchronous snapshot deletion stuff has gone in now. I'm not sure about the other one that you're talking about. But the community tracks pretty closely behind. It's just a matter of testing and validating those changes on our platform. As far as our particular product, because we've been very conservative about this asynchronous copy on write fault resolution stuff, we're actually just before the feature flag integration. We're in the process of bringing that stuff into our product as we also try to push our stuff back into FreeBSD. Trying to think of what other things we're missing. As far as swap and dump, that's something that still needs to be implemented, although I think that
actually you can do them on FreeBSD because it's not optimally implemented.
Yeah. So I think that with the DMU work that we did, that we now understand what no-fill buffers are for, and we can implement that stuff now. So hopefully that'll get resolved pretty shortly.
I forgot to mention we're at ZPL 28 as well, and we're going to pick up the feature flags shortly. Cool.
Okay. And you were talking about changing attributes. FreeBSD has a very similar interface, so I think it's quite possible that over time the platform will share code and support interfaces, especially if they're close enough with semantics.
Yeah, I don't know if there's an official arbitration namespace for EAs, but we might want to pick one sooner than later.
Yeah, that's a good idea. I mean, with the feature flags, we were trying to solve the problem of the most changes that we had seen at Sun and illumos were in the ZPool versions, right? We have 28 ZPool versions, but there's only 5 ZPL versions, and I think since the SA stuff was introduced, Mark, how many things have we changed since that was introduced?
On the attributes?
Yeah, 1 or 2, 0.
Well, we have one that's going to come out in Solaris 11 update 1 that you don't know about.
Okay.
But for the most part, nothing has really been added. But we have added stuff, the extensible system attributes, which are a little bit different animal, and those are,
Oh yeah.
A Solaris that goes through the get adder add and
Yeah.
set adder add, which is more of a get set model.
Yeah. So I think that's something that we didn't really anticipate when we did the feature flag stuff, but I think that's a great idea that we should try to standardize the namespace of the system attributes and try to get some integration across the different platforms, especially with the other way of doing extended attributes that's very common on these other platforms.
Well, the one thing I would say though, like right now we have, if you want to have just a get and set model, it might be more appropriate to create something analogous to the Sun W adder extended attribute. You could have a, kind of a illumos perhaps, which and then you can code it in that your namespace.
So that's something that's similar to this get and set based thing that we have in.
Well, it was all done for the SMB support, so that you get the archive and the system bits
Right.
and so on.
Right.
You can also get the SID information out of that.
Yeah, but I think the difference is that those are things that aren't we implementing, like they have defined behavior that the system implements, right?
Right.
Versus,
The way you set those is you ultimately have to do like a plot set adder or a plot get adder from the FS code, the ZFS layer, and how they are stored in the file system is sort of up to ZFS to determine. And in some cases, they are encoded in another attribute, but you could also add a new system attribute just to hold the storage of those.
all right, cool, thanks.
All right, so now we wanted to talk a bit about tools for observing and debugging ZFS. and what you've got on each of your platforms, whether you ported the original Solaris tools, such as ZDB or ZFS MDB modules, or dtrace, or you have integrated with platform-specific tools on your specific platforms.
Yeah, I guess you already mentioned the ones that are available in illumos, like Z-test for testing, ZDB for debugging on disk format, the MDB modules, which we've done a little bit of work on in illumos recently, and then of course dtrace. So there's a bunch of statically defined probes in ZFS for monitoring like IOs and the sync task stuff. But actually, that's an area for that needs a lot of improvement, I think. I mean, we've talked about making like a ZFS dtrace provider that would allow you to have very well-defined probe points for instrumenting like all the IOs and being able to correlate IOs with the user's activity. So right now you do the IO, but that's been aggregated and sliced and diced 7 different ways from what that user actually requested. So correlating that is a bit of a challenge, and I think that's something that we want to address with the ZFS dtrace provider someday, somehow.
So for Linux, we ported the usual set of tools that are more ZFS specific. So we've got ZDB, we've got Z-test. Those are there. We didn't port over anything from dtrace. In fact, we used the standard Linux debugging tools. So that's ftrace and system tap these days for grubbing around in the kernel. We also use crash on the system. It's a nice utility for where you can run it on a live system or a crash dump to dig around in what was in core when the system crashed. But at the moment, we've also disabled the dtrace probes. Long term, we'd like to wire them into the Linux equivalent trace points, but at the moment, they're currently disabled.
How about into the dtrace on Linux port?
It's a possibility. I haven't looked at it at all, I confess. But if it works, yeah, I'm not opposed to it.
Cool.
Well, the Mac comes with a built-in file system exerciser called Spotlight, and so that actually found quite a few bugs because they traverse backwards from everybody else, so you find inversions in logs and things like that. But we use this thing called FSX, which Avi, I don't know if you remember from he did that back at Next, and it's a great tool for really finding edge cases in the I/O path between reader writers.
Test program or?
It's just a binary tool. You compile, and it's easy to, and it stresses out the paging and I/O stuff. And we found a couple inversions in there, and it beats it up. And if you can't run, usually if there's a bug, it'll show up really fast. It's and then a similar tool is FS Torture, and both of these are on there's a Forge Mac Forge site. They're both up there, but they're highly portable. So. Those are good. And we use, for aging is, I think, critical for ZFS because of its copy on write nature. So we use this tool. There was a fast paper a few years back it's called Impressions, and they had this model to basically age a file system over time. And so we run that constantly to sort of get a natural, sort of a more generic aging of the file system rather than just doing a brute force CP or something like that. That's like not as natural as over time going back and putting something in a folder. So you get, so we use that as well, and then
you guys have dtrace, right?
Yeah, we have dtrace, but some of the scripts don't work.
Do you know why?
I don't know, over time they just keep breaking things. So and the I/O in particular is tricky because it assumes you're wired into the sort of the DevFS stack, and we're not. We go straight to IOKit, so there's like probes that are not wired in. So I guess I need to provide a provider to do backend IO tracing.
So on FreeBSD, we do have a dtrace port. Unfortunately, the way that static providers are implemented in FreeBSD is not compatible with the way that they're defined in the standard Solaris or ZFS code base. So that's something that it'd be nice to find time to fix. At times when we've had to do debugging, we basically just define them the FreeBSD way temporarily. But since that's kind of a hack, I mean, the way they're implemented in illumos and stuff is the proper way. So we just need to address that issue. As far as debugging, one thing that our platform has that I don't know if any of the other platforms do, and that's Witness. It's basically a lock order reversal checking system. And in fact, some of the peripheral changes around our asynchronous copy on write fault mitigation code was to eliminate false positives or possibly positives, lock order reversals in the code, just because, you know, if Witness is really loud and annoying, you're going to start ignoring it, right? So the nice thing about Witness is it will actually tell you, you know, the 2 different ways or 3 different ways that locks were acquired, so you can kind of replay in your head and figure out and debug those issues. As we you know, work to clean up some of these issues inside ZFS, it'll be harder and harder to create lock order reversals, assuming that Z-test and the Solaris test framework or its follow-on for the ZFS test actually get decent coverage of the code. We also have, you know, built-in kernel debugger. I'm not aware of any additional hooks. I mean, we've done that for lock profiling and scheduler profiling and all these other kind of things in our kernel debugger, but we haven't, as far as I know, added any of that stuff for ZFS. Although there were times when Will and I were debugging stuff where definitely would have been helpful. I mean, traversing the lists as they exist in ZFS is just kind of a pain to do by hand, even with a GDB script or whatever. We do have KGDB and GDB over FireWire and things like that. A lot of our development was actually done on virtual machines, so we were using GDBSX on Zen in order to be able to do that. That required some hacking in order to get it to work, but that was also hugely beneficial. Trying to think, so scheduler graphs, Witness, lock profiling, KGDB, dtrace. I don't know, this is a giant kit of stuff.
We do have a report about the standard tool like the test and DB. We also have some error injection that we use to help test. We have dedicated tests into that test suite that we reported something about. And what that does is in some cases we'll actually directly turn off a file, a SAS file, to verify that that's the right thing. And also error injection, things like that. Of course, it has covered for that kind of thing in many other ways, but that's a little bit closer to the actual use case. So that's nice to have too.
And I forgot to mention, we also have ZDB and we did K-stats, and I think Linux did as well. So yeah. K-stats are actually really powerful
great.
for finding out information.
Yeah, I think we should coordinate on some of this stuff. Like, even if we can't actually share code, like, it would be cool if, say, we documented what ZFS MDB commands we have, so that at least, you know, you guys could see, like, oh, these are the things that have been useful to other people. So maybe, you know, we should implement something similar in GDB or, you know, whatever tools are there, and likewise the other way as well.
I feel a new community coming on. So the next, let's see what we go to the testing question. So what tests that we haven't already talked about can easily be run on your platform? For example, ZFS test, ZFS test suite, or any integration with platform-specific test frameworks that you haven't already covered.
I don't know, illumos has all the things that we've been talking about. I'm kind of curious for you guys, like, if Z-test is pretty easy to run, but like the test suite is probably more involved to port, and like if there's other platform-specific like test suites or infrastructure that exist on your guys' platforms.
So for Linux, there's been some convergence around a test suite called XFS tests for testing the in-kernel file systems. So we started running that on ZFS, and it passes that, and I've actually found a lot of good things. Beyond that, we don't run the ZFS test suite because that's really hard to port, actually. It's just not really technically challenging, but it's just very wired into Lumos or Solaris' way of doing things. So a personal thing I'd like to see done is a generic port of that for all the platforms. Like a version of the ZFS test suite that's not tied to any one distribution, really. It can be run on all the platforms just to validate them, that they're all correct and they're all implement everything right. I'd love to see some community effort around getting something like that done. Beyond that, for testing, I run Z-test always on the commits. A couple other benchmarks like FSX or basic I/O stressing utilities. One of the things I've found that's really critical for at least the Linux development, because we support so many different kernels on Linux and so many build environments, is that every commit that goes in our tree, right, gets run through 18 different platforms, 18 different Linux distributions, and all the tests get run on all of them in VMs. That actually catches a lot before it gets in the tree. So we're really good about trying to proactively catch everything that goes in the tree. Keep things in small commits so we can identify what changed it and just document everything we do.
We run Z-test as well, but we find hangs in there, and it has to do with in RP threads, if you don't initialize a mutex, it has side effects, and so that'd be one area of cleanup that would be nice, is that every mutex or every CV, everything has to be initialized, and there are places in the code, in the kernel side, that doesn't happen, and that causes some of these tools not to work. But I think that'd be a great Google summer of code or something like that, because I think pthreads is the standard, so you could actually probably distill out all that stuff.
It would be cool if you, since this is a problem like on your platform, if you could if you contributed up those changes to make it all initialize it, and then also something that can test it and verify it, so that then those of us on other platforms, where we don't have to initialize it, that it would catch it before we integrate, so we don't inadvertently introduce stuff that's going to break macOS. You could introduce some new checks in Z-test or something like that, so that
when we run in debug mode, we can tell right away, because it actually, instead of the lock bits, it's actually a pointer, so a big thing, and then when that pointer is null, it blows up.
So just like in Z-test or like in debug mode, we could just allocate a bigger structure, have some word in there that's tells us if it's initialized or not, and then whenever you try to use the mutex, it would check and see, was it initialized already? If not, then blow up, and then we can fix.
I think for ZFS debug, that should probably be the default case. It's pretty lightweight.
We actually have some of that already in Z-test for mutexes, but I'm not sure it's there for the condition variables.
All right, there you go.
Yeah, I mean, most of them all the structures are alloc at 0, but still, it's nice to. We actually have a bit in there, because we have 2 CV states. In Solaris, there's some, by contract, you're supposed to hold mutex when you signal and stuff like that. There's a few places where they don't do that, so we have to flag those. So we have 2 different types. We've been using FileBench lately, and that's another great sort of test tool. I mean, it's a benchmark, but it's actually a good driver of load. So we haven't put it back yet, but it's I think Stony Brook took over that, so that's a good one to have.
So on the Solaris test framework, ZFS stuff, that was kind of I shouldn't say that it was entirely our pain, because High Cloud Security did a pretty extensive port of that to FreeBSD. Spectre's done some cleanup, and we're trying to push that back to FreeBSD now, but it's definitely not complete. I mean, one thing that we did, for instance, is we did go through in places where there's specific zone commands and things like that aren't supported on our platform. We did put in a mechanism that allows you to basically say, not available on my platform. So those tests get skipped. But that probably could use some more refinement, things like that. And then, there's this, I just recently heard about the work that I think is being done for a simpler test framework than STF. Simpler is always better. So looking forward to that. Then maybe we can, codify the ideas of how to do the platform independent stuff in there.
Yeah,
so.
I think that's a great idea.
I think it'd be awesome if we had a common integration test suite. I mean, you could do something like have a framework that understands how to bring up virtual machines running different platforms. And if we had a way to, take our changes and test them on emails or Linux or Mac, and know that we're not breaking anybody else, then I think that would make it a lot easier for us to change the work. And then, ZTest has been something that has gotten a lot of focus to, not in a platform-specific way necessarily, but as I was telling Matt earlier, there have been some things that we found that are not very flexible enough in ZTest. So, for example, there's a big list of tests in ZTest, and they all have a certain associated frequency for those tests, and they get run. And we found that if you change the frequency of some of them, you would actually reproduce crashes much more frequently. And I think that we had to develop the test infrastructure better, and also to improve the test coverage.
You guys should talk here. You guys should talk with Chris Seiden, one of my coworkers. I can't see where you are. He's done a lot of work with the test suite and also with the automated testing with Z-Test in the test suite. And so we have like a kind of mini private cloud for testing in our at Delphix. So it would be really awesome to have like a test suite that can be run on all these different platforms, and we can just spin up VMs. So so that we can run all the different tests on all the different platforms before we integrate stuff. Great ideas.
All right. Ready for the penultimate question?
Sure.
So, assuming that I've decided I want ZFS in some form or fashion because I'm madly in love with it, why should I choose ZFS on your platform as opposed to someone else's?
So I guess
Bachelor number one.
Well, Deirdré, I'll give you ZFS. I guess illumos has traditionally been the platform where most of the development has happened, and the other platforms have been ports of that. I don't think that I think that we're seeing a lot of more innovation in other platforms. So I look forward to working with other platforms more as peers. I think that a lot of even ignoring that, I think ignoring the fact that ZFS, illumos is kind of ZFS's home today. I think that there's a lot of really great tools on illumos, like dtrace, like MDB, and just I think that illumos is a great platform with lots of tools that make it really good for deploying enterprise scale software. I'm sure everybody else is going to say the same thing, but their platforms. Yeah.
I would say the big advantage of Linux probably is the fact that it has such a large general community. Lots of people run Linux. That means odds are your network driver works well. Odds are you've got a driver for your disk. Odds are a lot of that hardware that you just bought that just came out is just going to work on Linux. So there's a good chance that whatever system you deploy, it'll just work, right? It may not be totally optimally tuned, you'll have some work to do there, but odds are the hardware at least will be supported. I also expect that the ZFS support on Linux will probably lag the illumos port for some time, right, where they're doing a lot of the leading edge development, but we try to aggressively keep up. So changes they make in illumos that make sense for the Linux port will get backported.
I think on the Mac, if you're already using a Mac, then I think you probably want to use ZFS, given what I know. You would ZFS's history, but seriously, I mean, with a lot of commodity drives, that's like the perfect candidate. You have a drive that may or may not be lying to you. ZFS will vet that out, and I'd rather know implicitly that my data is intact rather than throw the die and just like hope my data is intact.
So I think the choice of an operating system, sometimes it becomes a religious war. It's a very deeply personal choice. But the thing that I always take away from having integrated appliances and things like that on Linux, and FreeBSD, and other embedded platforms, is that it doesn't matter how popular your platform is, the drivers usually suck. Okay. And so you have to understand that when you go to actually turn something into something being production worthy, you're going to have to put in that investment anyway, no matter how much of a smiley face that FAE has when he comes to sell you, the LSI chip or the gigabit Ethernet chip or whatever, right? And I think that's still true of Linux. I mean, Linux probably does have better device support in general, or at least there will be a driver for that particular piece of hardware. But you better pick very carefully the hardware that you run this software on if you want to have good results. And I think that's true of whatever operating system you pick. As far as picking FreeBSD over any of the other choices, I think that the community, although not as large as the Linux community, is very vibrant, very mature, and also the way that we develop software is very, very mature. So the model of always, I mean, we've always had bug tracking, we've always had a kernel debugger, we've always been very focused on tools. And so for folks that are trying to do embedded appliances, and you'll see this, you know, Compellent and Case and Isilon and, you know, Juniper and Cisco with IronPort and TaxiMagic with the taxi meters in New York.
Network appliance.
Network appliance, yes, absolutely, network appliance. That focus on tools has really gelled with people that are trying to do embedded appliances. And so it all depends on what your use case is for ZFS. That's probably what's going to drive your choice of platform. But if it's the embedded appliance space, you know, a system that has that focus on tools and a mature development model, I think goes a long way.
So we had a question on the stream, which I think at this point in the discussion is probably in a number of people's minds as well, is that it looks to me like we have here the beginnings of a cross-platform ZFS community. And it says, the community seems fragmented. Would a ZFS governing body be workable? So cross-platform. Now, okay, this person doesn't know the history of the word governance in the illumos community, so we will forgive him for that. So some sort of higher power?
You know, I think, I don't know about you guys, but like, well, I know that we all here are engineers, right? And we all want to do the right thing for our platform and for ZFS and for the community. So, you know, I don't think that we need a governing body or anything like that. I think that we need to work together on an engineer-to-engineer level to make sure that our implementations are all compatible, that, you know, they all have the best features that are appropriate for every platform. I think, so that's kind of one aspect of what they're asking about. I think the other aspect is fragmentation. And I think that, you know, fragmentation is a real risk, right? Like different features are appropriate for different platforms. You know, things that are specific to, you know, macOS are probably never going to be in other platforms. But I wouldn't see that as like fragmentation in a bad sense. I would see it as specialization, right? File system touches a lot of different parts of the operating system, you know, as we've been talking about today. So I think the key thing is to keep the core of ZFS, you know, those middle layers that are the easiest ones to port, for all of us to port, keep those in sync, keep those the same, and also, you know, try to, you know, not fragment the on-disk format. So I think, you know, we've tried to provide good tools for that with feature flags, and I think, you know, we're going to need to extend that even further to, you know, the system attributes. But I think that you know, the code is going to be a little bit different on every platform because it touches these very platform-specific things. So I think it's a balancing act of how much we keep in common, how much is specific, and I think that we're going to have to work towards making that common code even more common, and so that there won't need to be as many changes on each platform.
I would agree with all of that. I think the key bit is to keep it portable between the platforms as much as possible, and that means a lot of engineer-to-engineer communication to make sure we don't do anything that breaks that portability. I think you're always going to have some integration-specific bits on each port, and I don't think that's a bad thing because all of our operating systems are so different that for it to work well, you just have to have that. But as long as it doesn't break major portability, then I think that's okay.
Yeah, I mean, I don't see it as being fragmented. I think a lot of things complement, and some of the features come out of just the differences.
Yeah.
So from my perspective, the biggest risk for fragmentation is finding the time to extract the changes and push them up in a coherent way. And in order for that to really happen, we have to motivate, you know, the management of our companies and things like that to allocate the time so that those bits can flow the right way. So, I mean, as far as like our copy on write changes that we did, right? Spectre doesn't care whether we give them up or not. It's just, they do care about how much time I spend giving those things up, right? But there are some strategies that can be employed to help that. And one is, for instance, Spectral Logic being in kind of an archive business, long-term data retention business, it's kind of nice to be able to go to your customer and say, there is no vendor lock-in on this data. Okay, we're using an open exchange format that is also supported on the other platforms. And in certifying this platform, we've also verified that you can read it with Linux, you can read it with OS X, you can read it with illumos. And so talking about how to, talking to your management about the value of staying together on at least the core data format, I think is the best way to prevent fragmentation.
And I know I keep it fairly in-depth, but I really do think that it would be very helpful if we had, for example, a reference implementation where basically we collaborate and record ZFS implementation, and then you have infrastructure built around that in order to push back changes that occur among the platforms, and then you can build on top of that the test infrastructure needed to keep everything working well for everybody.
Yeah. If it's tested, it'll work.
Yeah, exactly.
Let's take a couple. Can we take a couple questions from the audience? Yeah, let's just get that in.
Okay, so we've got time for a couple of quick questions from the audience. Does anyone here in the room have questions?
Specifically for Linux, is there any prayer of NFS v4 ACLs ever actually working anywhere in Linux other than in weird code forks that are unmaintained? This is relevant both to ZFS and to NFS v4. So,
can you repeat your question?
So the question was, as I understood it, is there ever a chance of Linux actually honoring NFS ACLs as they were implemented? I'm not too versed in ACLs, but I do know there's a recent initiative on Linux called Rich ACLs, which is yet another ACLs format that should encompass both of them. I don't know if that's getting any traction in the Linux community or not, but it's one possibility for that being supported in NFS. As for ZFS supporting NFS ACLs on Linux, yes, after a fashion. So there are patches out there floating that haven't been merged into the Linux tree yet that'll convert not perfectly from NFS ACLs to POSIX ACLs so they can be used on Linux and back again. And we'll probably merge that into the ZFS tree and it'll be done seamlessly so that it'll look like it works, but there will be some caveats there because it's not a perfect translation. But
it's a user space tool, which is why I was asking community-wise. I don't know the community acceptance.
So I don't know about, so the question was about user space tools. So once again, on Linux, you'll get the POSIX ACLs tools, right?
I think that was Linux specific. So, any more questions? George?
So, kind of to Will's point about having like a reference development, do you see any value in having a common ZFS community like mailing site? Today, every distro, every platform has its own ZFS Discuss mailing list.
And I subscribe to all of them.
Yeah, and we obviously see cross posts, on some of them. Is there value? Do you see value in actually trying to merge that into one kind of common ZFS Discuss list for all platforms?
I really don't know. I think that one of, as we were kind of talking about why you choose one platform over another, I think a lot of it is community, right? I think that's kind of, to paraphrase each of our answers, I think that's what it boils down to a lot in a lot of cases. So that's a very kind of social aspect of how things are done. So I don't think that, I wouldn't want to force that on anyone else. I guess I would put it that way. Obviously I would invite anyone from any platform to come talk about their platforms on the illumos ZFS mailing list, and I'm certainly concerned about how ZFS works on any platform, and I hope that that goes for the other people that are developing ZFS on illumos. But there are kind of different concerns on different platforms, like on Linux, where you're having 700 commits in 2 years. That's probably, a lot of that is Linux-specific stuff, right? So there's definitely a place for community-specific mailing lists as well.
I would say that it may make sense to have both, actually. I think having a platform-specific mailing list makes sense because there's a lot of platform-specific questions that come up about why this or that was done on your platform, and it makes sense to have a community that's familiar with that particular platform. At the same time, it probably makes sense too to have a broader community mailing list where you can ask questions of just generic ZFS questions. So I think there may be a place for both.
I completely agree with Brian. I think that it makes sense to have both.
So I think that that does make sense to have both, but there's also a second component of that, and that's kind of educating the community, at least as far as the platform-specific mailing lists are concerned. Because one thing that's been interesting for me in coming to this event is understanding the differences between the different platforms and also the different use cases. And some of the use cases aren't related to platform, right? But they just happen to have been developed on a particular platform. So understanding those differences, I think, is important as we, in our individual work experience, trying to get stuff to go faster, or keeping those in mind so that our optimizations are compatible with other platforms and other use cases. So, so I think it's really important to make sure that when you do see something on a platform-specific list that you think bears a more general audience, to basically pass that on.
And on top of that, having a ZFS reference implementation would help everyone if we turn it into basically defining a core piece and having standardized interfaces that every implementation has their own version of. So.
I think Will wants a reference implementation.
I think I saw one. Did somebody have their hand up?
There was one other interesting question on the channel here.
Oh, okay.
Encryption.
Oh.
So I tried to get you out of it.
Yeah, I think this gets to something I was thinking about when we were talking about compatibility, which is
missing a chair. Is what
yeah,
say.
Exactly. So Oracle isn't here at the table, and I think that is literally and figuratively the case. Unfortunately, thanks for coming, Mark, being the face from the back. But I think I would love to have compatibility with Oracle's ZFS implementation, across the board for as far as on this format goes, including encryption and all that stuff. How or where that happens, I don't really know. I would love to kind of work with anybody who is interested in working on that and has this time and skills. And I think encryption would be great, but I think there's also there's other ways to do encryption besides the way that it was done at Oracle. So I think there's specific platforms, some platform-specific encryption tools as well. I think that might be relevant here.
So I'd agree with that. I mean, we'd all love to see ZFS encryption, right? But that isn't completely up to us. As for platform-specific tools, yeah, I mean, all the platforms, maybe not all of them, but I think most of them offer some form of encryption that will work in ZFS, right? Either underneath it at the block layer, like something like Lux on Linux, or maybe just files-based encryption.
Similar on all the platforms.
And there was one more question here.
Yeah.
I think that's you.
First was encryption, thank you. Second is, where is the centralized comprehensive Blackguard's recovery strategies archive I can turn to?
I think, George,
It's to ask George, apparently.
Yeah.
No, George is the answer, right?
Well, I know.
Shipping to George and everything.
Yes.
So my experience with regards to recovery is that almost every scenario has slightly different. So having something that's very comprehensive is difficult now. At the beginning of time, like there was a lot of discussion about like having some FSCK-like facility. I think that if you work with ZFS long enough, you see that that really isn't necessary. And even when I go back and look at cases where I've manually done recovery, a tool like that wouldn't help you. There are probably things that we can do as a community to start building some better tools and potentially ways to automate some of the importing a tool, even if it's read-only or crippled, or you can only get 1 or 2 file systems off of it. there are some things like that that could be developed.
Documentation? Do you want, would it make sense for you to write up some of your experiences for?
Yeah, well, I can definitely put some stuff together of things that I've encountered and tricks that I've used to try to recover pools.
Anybody else have?
Significant risk is to make things even worse following those recommendations.
Yeah, you have to be a real expert to use those tools because they are power tools without any guards on them.
Which
like the crazy things that George has done.
I don't know, like, it would be interesting. I mean, my experience has been primarily on illumos-based pools, but I don't know if people have had to deal with recovery or things on other pools. I know I've worked with somebody from FreeBSD who actually we ended up pulling the pool into illumos so that it would be easier to recover. But you guys have had any experience with that? Should be thankful if the answer is no.
Yes, so far, no.
But certainly the read-only and the -F and those type of tools actually help to get you to a state where you can actually just copy data off.
All right, I think we'll call that a wrap. Thank you, my handsome bachelors.